Hey guys, today we're going to go into applications of quadratics, but first I'd like to remember our 4 methods to solving a quadratic equation. Method 1. You factor. If possible, factor your polynomial completely and set each factor equal to 0. Option 2. Taking square roots. You can do this when you only have a quadratic term and no linear term. For example, something like x squared equals 36. You simply square root both sides to isolate the x and get rid of the exponent. Number 3, we can complete the square. Number 4, we can use the quadratic formula. And again, as a reminder, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. From here, we'll talk about which method you should use. We talked about this a little bit yesterday, but I'm going to go ahead and recap it for you again. To determine which method you use, the first question you should always ask is there a linear term? If not, then you need to solve by taking square roots. If there is, then we need to choose another method by which to solve. Step 2. If we cannot solve by taking square roots in step 1, then we move on to step 2, which would be factoring the equation. If the equation is factorable, then we solve it by factoring. However, if it's not factorable, then we solve by another method, and that would bring us down to step 3. Your last option would be to complete the square or to apply the quadratic formula. So on the right, I'm going to go through and check which method I should solve each of these by. I won't actually solve them, I just want to verify which method I should use. So question 1, is there a linear term? Here there is. We're looking for the term raised to the first power. Here 6v is linear while 3v squared is quadratic because of that exponent of 2. Since there is a linear term, I move on to step 2 and I see whether or not it's factorable. So I subtract 2 from both sides to get a 0 on one side, and I have 3v squared plus 6v minus 21 is all equal to 0. Since everything has a 3 in common, I divide everything by 3. This helps my numbers be a little bit easier to work with. So I have v squared plus 2v minus 7 equals, and 0 divided by 3 is still 0. So setting up my diamond, I multiply my negative 7 by my leading coefficient, which is 1. Those two multiplied give me a negative 7 on top of my diamond, and on bottom I have a positive 2 from this middle coefficient. I need two numbers that multiply to negative 7 and add to negative 2. And since there are none, we cannot solve by factoring. So what I do instead is I go to the last step, step 3, and I either complete the square or I may use quadratic formula. In the middle, question 1, is there a linear term? So I'm looking for just an x term. Since there is no linear term, what I'm going to do is simply isolate that x squared and square root both sides. So all I'm going to do is take square roots to solve. Last, question 1, is there a linear term? And there is. This negative 20x is the linear term, so I cannot square root both sides. Question 2, I need to determine whether or not the equation is factorable. So I subtract 4 from both sides to get 10x squared minus 20x minus 30 equals 0. And I see everything is divisible by 10, so I divide everything by 10. And again, this helps my numbers be just a little bit easier to work with. When I reduce, I have x squared minus 2x minus 3 is equal to 0. To check whether or not it's factorable, I set up my diamond. Negative 3 times my leading coefficient of 1 is negative 3. That goes on top, and negative 2 on bottom. There are two numbers that complete this diamond, and that would be negative 3 and positive 1. Since there are two numbers, I solve by factoring. The other thing I talked about in our most recent lesson was simplifying quadratic solutions completely. So I'm just going to go ahead and do one of those, and then I'll leave the rest up to you. I'm going to go ahead and proceed to solve this by the quadratic formula. Step 1, make sure it's equal to 0, which it is. So step 2, I list my a, which is 5, my b, which is -2, and my c, which is -4. Plugging these into my quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. I have negative b, which is a -2, plus or minus the square root of b squared, so -2 squared, minus 4 times a, which is 5, times c, which is -4, all over 2 times a, which is 5. This -2 in the front becomes a +2 plus or minus the square root of +4. -2 squared is +4. -4 times 5 is -20. Times -4 is a +80 all over 10. From here, I simply add inside the radical 2 plus or minus the square root of 84 all over 10, and I simplify that radical. I can break it down into 2 and 42. 42 can break down into 2 and 21, and 21 breaks down into 3 and 7. I'm simplifying the radical. It's a square root, so I'm looking for groups of 2. So I can take that group of 2 out, leaving me with 2 plus or minus, and I'm taking a 2 out of the radical, but I'm left with inside the 3 and the 7, which multiply to 21, all over 10. Now all 3 of these terms have a 2, so what I'm going to do is simply factor out a 2 from the numerator. That leaves me with, when I take a 2 out of this 2, 1, plus or minus 1 rad 21, or just rad 21, all over 10. Now, since I am multiplying this 2 on the front, and I'm not adding or subtracting anymore, I may reduce with the 10 in the denominator. These cancel, and in the denominator I now have a 5. So my new expression is 1 plus or minus the square root of 21 all over 5. Go ahead and take a moment to pause the video and try the next few on your own. I'm going to go ahead and move on to the next slide. Here we're going to go into applications of quadratic equations. In this first example, we have a carpenter making a rectangular tabletop, where the width is x minus 1 feet, and the length is 3x plus 1 feet. The total area is 39 square feet. Find the dimensions of the tabletop. It might help to draw a picture. Anytime you're doing an application, I always suggest drawing a picture. So here's my tabletop. It's a rectangle. The width is x minus 1, and the length is 3x plus 1. The total area is 39 square feet. So what I need to do is I need to write an equation relating everything that I have. Well, I know the relationship between area, length, and width in terms of a rectangle, and that's that area equals length times width. So all I'm going to do is plug in all of the information I'm given. For A, I'm told that A is 39, so I plug in a 39. For L, I'm told that L is 3x plus 1, so I'm going to plug that in, 3x plus 1. And for W, I'm told that W is x minus 1, so I plug in an x minus 1. From here we need to solve, but before we do so, we need to put this in the proper form. So I'm going to distribute my 3x. On the right, I have 3x squared minus 3x. I then distribute my positive 1 to get plus 1x minus 1. All we are doing is applying the FOIL property. We're simply foiling to expand this polynomial. From here, I'm going to simplify the right-hand side. 39 equals 3x squared, and I can add these two together to get minus 2x minus 1. I'll go ahead and get a 0 on one side so that we can decide which method we should use to solve it. I have 0 on the left, and that equals 3x squared minus 2x minus 40. Now the first question is there a linear term? And here this negative 2x is a linear term, so we cannot solve by taking square roots. So we can either factor or use the quadratic formula. Let me check and see if factoring will work. I multiply negative 40 times 3 to get negative 120, and I need to add to a negative 2. My two numbers here are a negative 12 and a positive 10. So since I can factor this, I'm going to go ahead and solve that way. So 0 equals 3x squared. I'm going to split up my negative 2 as negative 12x plus 10x minus 40. Split down the middle and take out a 3x, leaving you with x minus 4. And on the right, take out a positive 10, leaving you with, again, x minus 4. So I take out that x minus 4, and I'm left with 3x plus 10. All of this is equal to 0. From here, we write two equations, and we solve each. X minus 4 equals 0, and 3x plus 10 equals 0. When I solve the first, I find that x equals 4. And when I solve the second, I find that x will equal negative 10 over 3. Since I want the dimensions of the tabletop, I'm going to go back and plug this in. Taking my x and plugging it in, w is going to equal 4 minus 1, which is 3 feet. And the length is going to equal 3 times 4, which is 12, plus 1, which is 13. Plugging in a negative is only going to give me negative length and width, so this cannot be part of our solution. So our two answers are that the width is 3 feet and the length is 13 feet. Go ahead and take a moment to pause the video and draw a picture setting this one up and solving it on your own. You should have set up your width as just w and your length as being 2w plus 4, since your length is 4 more than 2 times the width. Area equals length times width. Area is 400, length is 2w plus 4, width is w. So I distributed my w, and then I subtracted the 400. Once I got there, I saw everything was divisible by 2, so I divided everything by 2 to get here. Now once I'm here, I set up my diamond. I need two numbers that multiply to negative 200 and add to 2. There are no such numbers, so I proceed to use my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Here your a is 1, your b is 2, and your c is negative 200. Plugging in my b, I have negative 2, since b is 2, plus or minus the square root of b squared, so that would be 2 squared, minus 4 times 1 for a, and negative 200 for c, all over 2 times 1 for a. So that's negative 2 plus or minus the square root of 4 plus 800 all over 2, which is negative 2 plus or minus the square root of 804 all over 2. Factoring down my 804, I see it can be reduced to 4 and 201, or 2 times 2, which does pair up, so it gets to come out of the radical. So I have negative 2 plus or minus, I'm taking out a 2, and I'm left with the square root of 201 all over 2. I can factor out a 2 from the top, so I have 2 times negative 1 plus or minus the square root of 201 all over 2. And now I can reduce these 2's, leaving me with just negative 1 plus or minus the square root of 201. There are a couple more on your notes that I would like you to try, so please go ahead and do so. Do your best to draw a picture and set them up, and solve them if you're able. Thanks so much for watching. Have an awesome day.